Welcome back. Despite the Apple keynote going on, so I don't have one more thing to announce. So hopefully it'll be still exciting. So thanks for joining me right after lunch. I'll be speaking about Groovy in the light of Java 8. So what the fact that Java 8 comes loaded with interesting new features, new APIs, new syntax, etc. What does it mean for Groovy developers? And is Groovy still attractive, etc. So that's the kind of questions we'll try to answer. So I'm Guillaume Laforge. I'm the lead of the Groovy project, and I work for Pivotal. And you can follow me on Twitter there. Forgot to put it in full screen. Like this morning, a bit of marketing. There's the Groovy weekly newsletter if you want to receive updates every Tuesday about the latest and greatest about the Groovy ecosystem, Grails, Gradle, etc. I invite you to join this newsletter, this mailing list, basically, and you'll receive the latest news directly in your inbox. We've got some Google Plus pages and community if you're interested in. So we don't make much buzz around those two pages and community, but if you're on Google Plus, we share some interesting bits there too. So the goal of this talk, I've had some, especially Java developers, not necessarily very well versed into all things Groovy, who asked me the question, do we still need Groovy now that we have Java 8? And after all, it's a pretty valid question. And sometimes Java developers think that, okay, there are lambdas now in Java 8. So, I mean, what's the point of Groovy with its closures? Well, but fortunately, Groovy is much more than just closures or lambdas. And we do as well more with our closures than with their lambdas. So it's interesting to take that question and see what the impact is. So to those who said, no, don't need Groovy anymore, get out. You can watch the Apple keynote. OK? For those who said, yes, you can stay here with me. So more precisely, will Lambda replace our closures? Or what are the differences between the two? Java 8 comes with new APIs, but also new syntax constructs. So will Groovy adopt those syntax constructs as well or not? Or we use what we have already in Groovy, but enhance potentially with missing aspects or things like that. And then perhaps also more for Groovy developers per se, how Groovy developers can benefit from Java 8 because of those new APIs. Can we use them? What can we do with them? Is there some Groovy facilities, some Groovy syntax sugar or added methods on the GDK, etc.? But beside that, beyond Java 8, what does Groovy offer? That's the kind of questions we'll be trying to answer in this presentation. So if we try to make a little parallel between the two, there are definitely some, if not redundancy, at least things which are related. So obviously, we had closures back already in 2003, and lambdas are coming now, at least in Java, which is, I think, a good thing, even if now we have two concepts to deal with. We have traits in Groovy 2.3, which works on JDK 6, whereas the default methods in interfaces are really just for Java 8. And so far, there aren't many guys using Java 8 in production. Is there anyone using Java 8 in production? A couple of hands? Yeah. So that's the usual percentage that we get. There's an interesting class called optional in Java, but we've got some cool tricks to handle the truth and null handling, the Elvis operator, etc. So how it relates. We'll see how we can improve optional from Groovy. We've got the stream API in Java 8, but with Groovy, with the methods on the JDK, we've got collect, find all, etc. So we had similar concepts. And last, I'll mention also the method references, which are similar to our method closures, or sometimes called method pointers. But method closures is the more the better name. So, is there redundancy? Should we? How are we dealing with that? So, we're going to cover a little bit of those new things in Java 8 and contrast that with Groovy. So I'm not doing, first Java 8 talk, then Groovy talk. I'm really mixing the two together to contrast the two and see how they complement each other, how they are different, and also at the end, I'll show also beyond just the syntax or the API, how Groovy adds its own twist to the story. So the new things on Java 8, first of all, little disclaimer, because it's really, I'm not going to go very deep in all those Java 8 features, but I'll use them to illustrate, I'll illustrate them and contrast them. So if you want to get the very tricky details about Java 8 lambdas and type inference or whatever, it's not for this presentation. But we want to understand the implications with regards to Groovy. So in Java 8, the new syntax, but there are also various aspects on which they worked on, the Oracle engineers worked on, like the streams API that we'll mention, the date-time API. I'll also speak a bit about the Nashorn JavaScript engine. And this page on the Oracle website is quite concise and covers the novelties. So if you want to dive a little bit deeper, that's where you should be heading if you want to get all the details. So the new Java 8 syntax, lambda expressions, method references. You can have static methods in interfaces, default methods, the repeating annotations on all types. And the other two, we won't really mention them. So we'll focus on the first ones. Improved type inference, it's not really relevant for this talk. And method parameter reflection, I'm not mentioning it, but it's a way to get access to the names of the parameters of your methods with reflection. That the Oracle decided to not enable that feature by default, like assert, which is a bit sad because that would have been nice. So I'm not really mentioning that. So first of all, come lambdas, right? So an example of lambda expressions. So you've got a stream of students, and you're going to filter the students by graduation year. Then you're getting the scores, and then you're trying to find the maximum. So the students, the maximum score of the students of year 2011. So it looks like that in Java with this notation. So you pass inside the parents a lambda, and you can identify the lambda with the arrow sign, like in our Groovy closures. The parameters are here, and then the expression is there. This lambda expression is actually converted into what they call functional interfaces. So that's a function with one non-implemented method. I say non-implemented, although it's an interface, because now we can have default methods which provide an implementation. So the single still abstract method of that interface. And in Groovy, there's something I can mention as well is that we coerce into that functional interface. So there are many new functional interfaces like supplier, consumer, predicate, etc. And some of the existing things like action listener kind of classes are often functional type kind of interfaces. but there's no actual type. Compared to Groovy, where we have Groovy lang.closure, which is there's the real object for our closures. In Java, there's no class. So you cannot call methods on a Lambda expression. So that's why I mentioned that there's no function type, because it's coerced into a functional interface. And what's interesting as well, and to contrast that with Groovy, is that when we are doing that, we're actually building a pipeline of operations. So even if we did several filters or several map conversions, it's only as a last step or on certain methods like max, where we go through the stream. And that's important because there's really just one pass compared to what we've been doing so far on Groovy, where each time we were doing, let's say, find all, collect, etc., we were creating intermediary collections. Here with Java 8, that's not the case. That's really one single pass. But more recently, the Groovy JDK has been adding some iterator-based variants for some of these methods. And when you use the iterator-based versions, it's also more like the pipeline approach, because once you, let's say you do each at the end to iterate over the collection, you're going through the iterator, and it's done in a way in a single pass, if you will. Now, if we take this Stream API and try to use Groovy with that, well, it's pretty similar. And what's interesting is that we can use Groovy closures wherever you can use Lambda expressions. So here, instead of the parents and the Lambda expression syntax, we have our Groovy closure syntax. So instead of what was that? A filter. Instead of filter, we have find all, and instead of map, we have collect, and then max is still the max. So it is the default parameter, as usual. And also notice, of course, that we can use the property notation. So get grad year is shortcut to dot grad year, the property notation. So that's interesting to note that although we don't support Lambda expressions in terms of syntax, wherever Lambda is being used, you can use Groovy closures. So as I mentioned, if you use the iterator variants, you can get the same kind of pipelining as Lambda expressions. But I think, to be fair, really Lambda go a bit beyond what those Groovy JDK methods did. So here it's really with the JDK, but I'm going to show you the example with the Java 8 stream. Actually, I thought I had the so basically you can use, I should have put the intermediary slide where I really use the stream API like I did this morning in my other talk, because you can really use the filter and map methods with the Groovy closure. Here in this second example, I'm using the Groovy JDK, but it also works with the stream API, of course. Okay, up. There are, or perhaps I've got the slides afterwards and I forget the order in which I'm showing things. So there are different variants for the Lambda syntax. When there's one parameter, it's pretty much like the inside of our Groovy closures. When you've got several parameters, you have to surround with parents there. And here, if it's an expression, you don't need to have curly braces. But here, where I'm using a statement, I can, or if you have several statements inside, you have to use curly braces. Here, also, something I'm not mentioning, the return keyword, just like in Groovy closures, is omitted. You don't have to use it. You're not allowed to use it even. Here in this Lambda expression, if I were returning something, the return keyword would be mandatory when we use curly braces. It's required. And in some cases, if from the context the type of the parameter can be inferred, you can also omit the type information, and that's the Java-C compiler, which will figure out the right type. So it can be even slightly shorter. Up. And actually in this example, I'm going to show you how you can put closures instead of lambdas. So this is a couple of examples where I'm creating an int stream, a range from 1 to 100. And for each of these ints, I'm going to print the int. In the other example, I have these files, utility class from the JDK in Java new IO files, which got a lines method, which is new in JDK 8, which create a stream over the lines of the file. And here, instead of doing new file like pre JDK 7, you can do path.get to get access to the file and get a path object. And then I'm doing map, transforming the lines in uppercase, and for each, I'm printing the line. Here, this time, at least, I'm really replacing lambda expressions by Groovy closures. So here, at least, you can see, the proof is on the slide, that I'm replacing the lambda expressions with Groovy closures as we are doing the coercion mechanism to transform the closures into the functional interface, the various functional interfaces that are used throughout the Stream API in Java 8. So, and also one point where we also go beyond just functional interfaces. I mentioned that functional interfaces are about interfaces with one single abstract method. So one method which is not implemented in the interface. So I'm not speaking about default methods, but we also support that with abstract classes. So if you have an abstract class with one single abstract method, we can do the same mechanism to coerce the Groovy closure into that abstract class. So we go a bit beyond what Java does with lambda expressions. But beyond the syntax itself, Groovy adds some other things, other features to its closures. For example, we have default parameters. So here I've got a multiply closure where I multiply A and B, the two parameters. So if you call with true args, okay, so A is going to be 2. I'm going to put 3 in B. So 2 times 3 equals 6. But if you just pass one parameter, so you've got 5, which goes into the A parameter. But since you didn't specify the second parameter, B will be 10. So 5 times 10 equals 50. Another interesting thing is, thanks to the fact that Groovy is a dynamic language, with duck typing, if you're not using static compilation, etc., sometimes our Groovy closures are a little bit more polymorphic than pure lambda expressions, because here in my adder closure, I've got A and B, and I'm going to add the two together. But I didn't specify the types of A and B, okay? So if I call adder with 100 and 200, we're going to do an addition of numbers, so it's going to be 300. But if you are adding two strings together, we're actually concatenating strings. So it's going to return X and Y, concatenated. So this, those two calls shows that you really just need one adder class to do two different kind of additions, concatenation and a number addition. So this closure is more loosely typed and actually takes more more types for the entry parameters. And if your class is implementing a PLUS method, you can use this adder closure and add those things together because of that convention, which is to have two things which have a plus method. So this is a bit more, I was going to say generic, but generic is a bit of an overloaded word. So it's more about polymorphism, the fact that you can do more with the one closure because of duck typing, because you're omitting the types. Okay. Another interesting things which is enabled by builders, by closures, that's our builders. So the markup builder, the JSON builder, XML builder, etc. So builders, if we were to implement builders with Java Lambda expressions, what would it look like? And aren't Groovy builders more powerful? So let's see. There's this example. I forgot to put the link, but it's an example that I simplified a little bit, but that's coming from an article which was on the DZone. So I took a bit of inspiration. So the article actually mentions Groovy builders and showing how you can do builders with Lambda. And if you know the markup builder, so this is yeah, it's not the same type. I probably made some changes in the slide. So here, the idea is to build a POM, a Maven POM representation. So I shortened the example because it was showing more stuff to generate. But here, that's enough for the purpose. So here, you noticed, first of all, that we have to repeat POM a bit everywhere because there's no notion of delegate like you have with Groovy closures. And also another thing that you'll notice is Lambda expression taking 0 arguments. You still have to use parents. So you need an arrow, and you need to have those empty parents to define those empty, so those 0 args Lambda expressions. So it's a slightly more verbose, I would say. And one more thing is the fact that you notice the EL and ELX methods, and which take the name of the tags we're going to generate. So it's slightly different from the Groovy version, where you actually can intercept method calls for model version, group ID, artifact ID, etc. And now, if you contrast that with Groovy, I would say, and hopefully you will agree with me, that it's slightly more readable. And of course, if you compare the two, if I come back here, and well, apart from the bubbles, it's, you know, we've probably got twice as many characters in the Java version, I guess. And it's much clearer already. You can spot, let's say, typos more efficiently and so on. So I created a POM builder class, but you could have used the markup builder class. So what do you think? Aren't Groovy builders more readable and lean? Yes? Anybody saying no? If anyone is saying no, get out of that room. So it's the leitmotif of the presentation. So another thing with our Groovy closures, that's how we muscle the brain of our closures with memoization. So when you do something like a Fibonacci call, a method, a Groovy closure with a Fibonacci, implementing Fibonacci. When you call Fibonacci of 10, it's going to call Fibonacci of 9 and 8, but if you call inside there Fibonacci of 9, it's going to call Fibonacci of 8 that we just called previously, etc. So we recalculate certain values time and time again. So it's not very efficient. So we need somehow to cache those values and get that in memory somehow. So that's the pattern of memoization. So you transform your closure with the memoize method, and it's going to return a new memoized closure. And that way you are able to call that as many times, and it's putting the values in the cache. And to be fair, we can also compare with we also have a memoized AST transformation. So this is not about closures and lambdas, but I wanted to highlight the fact that it's also available on methods. So this time this is a method, not a recursive closure. It's a recursive method. So we have that too. What else do we have? What am I going to speak about with that picture? Any idea? Tail recursion. Well done, guys. So this is tail recursion, chasing your own tail. So with tail recursion, so in Groovy 2.3, we added also a tail recursive AST transformation. But if you want to do that, implement tail recursion with closures, we've got this trampoline method. So the inner trampoline call, fact call, and actually I think it should probably be, there's a mistake, it should be, I should define fact before because it wouldn't work there because fact is not yet defined, but never mind. So here it's the recursive call, and you have to do it here and there as well. And also sometimes what's that I mentioned this morning as well is that you really have to make the code tail recursive friendly in the sense that for calculating factorial, we could have said n times factorial n minus 1, but it's not the last call which is factorial. The last call would have been a multiplication between n and factorial. So here I slightly rewrote the example in order to use an accumulator so that I can really have a way to have the last expression here being the recursive call. So that's something. The tail recursive transformation, for instance, or the trampoline call, they cannot really change your code to make them tail recursive friendly. So you might have to do that yourself. But otherwise, once you've got the right form, it's really in the case of the method, with the tail recursive AST transformation, it's the transformation which is going to do the right transformation to serialize those calls and make them more avoiding to blow the stack with a Stack Overflow error. So our closures go slightly beyond. In Java 8, there's now method references, so that's a kind of a way to have a pointer over a method. So in this example with let's say something that looks like a Swing API. So button, if you want to do something when the button is clicked, for instance, you might be, let's say, printing the event. And if you want to use method references, that looks like that. So you can say, with the double colon here, it's a kind of a pointer, it's a reference to the println method of the system out object. So this is what method references look like. There are actually three main use cases. Main cases, not use cases. So you can have a reference to an instance method of an instance. You can have a method reference to a static method of a class. And there's a third case, which is a reference to an instance method of a class. And actually, this one is not covered by our method closures, which look like that. So instead of the double colon in Groovy, that's dot ampersand. So they are doing pretty much the same thing, but this one, we don't support it right now. So what should be doing? We could adopt the double colon on the real Java 8 method references and deprecate, for instance, the dot ampersand notation. Or we could also enhance the dot ampersand notation to also support that third case. So it's a possibility. But it's really not just about the syntax and that case which is not covered. It's slightly a bit more complicated under the hood because of how, let's say, the Java 8 compiler does type inference, etc. So it's not just as simple as a syntax choice, but basically, to make it simple, I mentioned the syntax. And by the way, if we were doing a show of hands, what would you think we should be doing? Just enhance the Groovy notation, or adopt and support both, or deprecate one or use the other, etc.? Do you have a preference? Java is the syntax, and even dropping the Groovy syntax itself. Okay, that's interesting. Sorry, Peter? An extra vote for that. Okay. So at the, yeah, right. So I definitely agree on the fact on not having, not adding confusion with having two different ways of doing the same thing, because then you have to guide users to say, okay, use this one in that case, use the other one in the other case, or that kind of guiding principles. Then there's the fact that if we favor the Java 8 syntax, that means it's going to be a breaking change. So that means that those who are using method closures will have to update their code. And yes, Cedric, you wanted to add something?
So there's another implication in dropping the Groovy syntax, which is that our method closures actually return a closure.
Yeah.
So you can manipulate the objects. So you can carry, for example, you can do something with the method reference.
Yeah, with the method closures. Yeah.
You can't do that because it's not the same object.
Yeah. So that's let's say a vote in favor of either supporting both or just keeping the Groovy. Yeah. So we have to weigh the pros and cons, and it's not an easy decision. And we've inside the Groovy core team, so we have 3 members there. There's Paul King, Cedric, and myself. And our colleague Jochen is in Germany. He's not there with us. And even, between us, we're still undecided what we should be doing. So the question is still open. And your feedback is interesting. And thanks for giving that feedback. In Java 8, we can add static methods in interfaces. So it's, when I was preparing those slides last week, it's interesting to see that there, in the various articles or books that I've read, they kind of mention static methods in interfaces, but it's kind of difficult to find good examples for that. And there are some examples in the Stream API, so it's a simplified version of the interface of the Stream interface of the Stream API. But for example, there's an empty method on Stream to create a new stream. So this is not how it's actually implemented. That's me making up this one. But it's inspired by the one from the available in the Stream class in the Stream API. And again, it's something that's, oops, sorry, I thought I had a bubble mentioning that it's not supported currently in Groovy, but we don't have any, well, apart from doing that dynamically at runtime, but it would be nice to be able to also support static methods in interfaces in Groovy. So it's something we should be supporting, and it's not a question of what do you prefer or not. It's really something that needs to be available if we want to be able to implement the same level and keep the same level of interoperability as we've always had in Groovy between Groovy and Java. So it's definitely something we'll have to implement. And also, there are implications in terms of course, of grammar. So we have to update the grammar a little, but this one shouldn't be very complicated to do, hopefully, with the new grammar that we are working on. In interfaces, you can have default methods in Java 8. So for example, here I have default methods to add stuff to a stream. So that's a default implementation. But then if you're creating your own custom stream, you may have a different way to add a new element to a stream. So at least for API evolution, etc. So the Stream API, excuse me, the Stream API is pretty new, so perhaps it didn't necessarily need to have a default implementation, but the default methods in interfaces is great for making evolution for existing interfaces, because if you want to add a new method in an interface, you cannot do that easily because you have to, it's going to break the code of all those guys who are relying on the interface contract. So that's a reason why they created default methods, to be able to enrich the collection classes, for instance, to add hooks to the stream API. And again, do I have a bubble? No. Again, it's a feature, although we have Groovy traits that I'm going to mention afterwards, although we have Groovy traits and the ability to add behavior in interfaces, well, in traits in Groovy, it's something we should be supporting as well, again, for the Java Groovy interoperability story. So I'm not asking your advice or your preference, it's really something we should be supporting. But yeah, I was mentioning traits. In Groovy 2.3, we introduced traits. So it's so I'm not going to go very deep, a bit less than this morning, and much less than what Cedric will be doing in his presentation on traits. So traits are like interfaces, but with method bodies. So it's similar to the default methods in interfaces in Java 8. It's a nice way to compose behavior. So if you have orthogonal concepts and you want to compose different behavior inside one and same class, you can do that. Our traits are stateful. It's something you cannot do with Java 8 because the default methods are not supposed to be used as traits, basically. So you can have properties like in Groovy classes, in POGOs, plain old Groovy objects. And traits also work very well with compile static and type checked. And the icing on the cake is the fact that those methods that we add to the traded classes is that those methods are really visible from Java. So a Java class will be able to call the methods adding by the traits. So some examples. So for those who were there this morning, that's the same. I think I've got 3 examples. That's the same as this morning. So a trait. Oh, I thought I had bubbles. So the traits. A trait is pretty much like class or interface, but there's a new keyword there. So I define a default implementation for that fly method, and then my bird class can implement that trait, can instantiate that bird, and checking that the fly method is available, and I'm asserting that it's the same outcome. States can have traits can have states. Sorry, not state can have traits. I don't know what it would mean. So here I define a property just like I would on a Groovy class. And again, my bird implements the named trait. I can use the map-based constructor, which calls the default constructor and then calls the setters afterwards. And then I can also use the property notation. And the third one is multiple inheritance in this example. So I have 2 surf methods in my 2 traits. And I create a special hipster person, which extends person and implements those 2 traits. And the last trait actually wins because that's the one which is declared there. But you can be explicit and you can reverse the order, etc. So there's we can go deeper into traits in Cedric's presentation. But that's how you can do multiple inheritance. So you extend a class and implement and get behavior from those 2 traits. So to know all about traits, no, it's not just, it's tomorrow? Or, no, it's, yeah, this afternoon, right. So that's just after the next slot. It's going to be Cedric on stage talking about traits and how to rethink API design with traits. So I really invite you to have a look at that presentation to know all the gory details and how to take advantage of traits. Annotations. So 2 things related to annotations. We've got repeating annotations. So you can repeat the same annotation several times, which wasn't allowed until Java 8. And you can put annotations on types pretty much anywhere types are being used. So repeating annotation, let's say you have a method and you want to specify a schedule for when this cleanup operation should be called. So it should be called the last day of the month and also every Friday at 11 p.m. And if you wanted to do that in Java pre-8, before Java 8, you would have had to create your own container class like @schedules, which whose value is a list of @schedule, is an array of @schedule annotations. And this now how you are doing that is that, so this is how the @schedule annotation is defined. But notice that we have @repeatable, and this @repeatable annotation points at the container annotation, so which is schedules dot class here. And this is the kind of container annotation that you have to write. Actually, you still have to write it. So it's in a way, it's more about syntax sugar. Even Java 8 adds syntax sugar. It's not just a Groovy. And so you still have to write that container. You still have to write, of course, this annotation as well. But you annotate it with @repeatable. And then you'll be able to repeat it without having to use the wrapper @schedules, parents, and then an array of the two schedule annotations. And currently, it's not supported in Groovy. It's syntax sugar. It's something we should be thinking about adding. And I don't think, I mean, grammar-wise, we don't have any restriction on things like having 2 times the same annotations, etc. So it shouldn't need any particular grammar changes, etc. So it's one of those features which shouldn't be too hard to support. And yeah, not yet supported, but hopefully soon. Annotations on types. So I give a few different examples. So you can annotate declarations, variable declarations, or field declarations. Field, you could do that already, but local variables can be annotated like that. Even when you do a cast, that's a little weird looking because we're not really used to that. So even in a cast, you can annotate the class there. Or this one might be more interesting. You can define a list of strings which are non-null. Or when you do new, you can put an annotation there in between the new and the name of the class. You can also annotate the exception. So throws @critical temperature exception. That's interesting. And also inside generics. Okay, yeah. So list, yeah. Well, it's basically more or less the same case, but so inside generics in the throws and in the implements clause. So that's the little addition. So I'm kind of mixing some of them on top. So again, it's something that's not yet supported. And this one will require a bit of rework of our Groovy syntax so that we can support that. And that's something we need to support. And what's interesting is the fact that it also means there are more targets for AST transformations. So an AST transformation could target a particular annotation. So it opens up some more fine-grained ways and places where AST transformations, local AST transformations can be triggered. So I let you imagine what we can do with that kind of code. For instance, for the static type checker, if you want to create a custom type checking extension that would check that the names that are put inside the list of non-null string, if those strings, if you see that something might be null, then you should be throwing compilation error. That's potentially the kind of extension you could be building. So that's something we need to support. But I'd like to highlight something related to annotations, which is specific to Groovy. That's our meta annotations. Sometimes you annotate, let's say, a service with the same couple or more annotations. So here, let's say that all my services are transactional and annotated with both add service and add transactional. So if you don't want to repeat yourself all the time and you would prefer just one annotation to point at those two annotations, you can define your own new annotation, which has got the two annotations there. So the ones we would usually put on the class, we're annotating the annotation itself, but we use the annotation collector transformation from Groovy. And then instead of add service and add transactional, you can just say add transactional service, my annotation. And it's a compile time thingy because it's at compile time that we are actually going to replace the real annotations with add service and add transactional. So if you do some reflection to see which annotations are available, or at least if the retention policy allows that, you'll be able to see not one annotation, but you'll be able to see add service and add transactional. It's really a compile time feature. And I'm not mentioning the more advanced cases, but if you have different parameters to your annotations, you can also handle those cases. You can also create your own, how do we call that, a processor, right? An annotation processor, which allows you to do something pretty clever. Let's say if you created a new annotation which takes, let's say, min and max parameters, but let's say the service max, the service annotation takes something called maximum instead of max, and transactional takes min instead of minimum, or that kind of things. Your custom annotation processor can actually dispatch stuff to the right parameter, etc. So it's quite advanced what you can do in terms of how you can mix together those annotations, even in the case of with annotations taking some particular parameters. So it's something which goes beyond what Java 8 does because it's not available there. Yep, that's yeah, you can create your own processor. Java 8 has got its own new APIs. So I'm going to mention the date and time API. So I just took a few examples that I found here and there. So you can define a new, so I used just local date, but there are many more interesting classes to the Java date time API. So I can define a new local date of now. I can say I want to adjust that date and do move that date to the last day of the month and remove 2 days. So 2 days, the payday might be 2 days before the end of the month. There's a nice notation for defining a date. So local date of 2012, May 14th. Again, an operation to add 1 year. And yeah, like finding, so what is this one doing? So the next way, yeah, the next Wednesday, you can say up with the temporal adjusters, the next day of week Wednesday. So it's going to find the next day. And something that you notice is that those operations on the dates, perhaps Groovy could add some operator of loading to do plus 2 days or that kind of thing. The kind of things that we actually already do with the Groovy time category. So if you use the Groovy time category, you can do arithmetics like 2 years plus 3 months plus 15 days, etc. So it's something we could, so although this is available on calendar, dates, etc., it's something we could do to enrich the new date and time and instant classes in the date and time classes. So this is the kind of stuff you can do with Groovy today, but it can help us get some inspiration about what we can do with the date time API going forward with Java 8. The stream API, so we already saw some examples. So this is there was a nice tweet that I kind of reproduced myself. This is a good explanation of MapReduce for my 6-year-old. So how you transform something into something else, and then how you reduce all those things to create some kind of output, the sandwich. So this other example is showing how, let's say you have a collection of persons, you retrieve a stream out of that collection, then you can do the filtering on the age, the transformation with transforming the name into uppercase and getting just those uppercase names, and sort that, and also join those names. So if we were to be using the GDK methods, that could be looking like that. And if you use the streams and the Groovy closure coercion to functional interfaces that we mentioned earlier in this presentation, it could be looking like that. So we can already use the Stream API thanks to Groovy closure coercion. And also, yeah, as I mentioned before, we make it work with abstract classes as well, not just functional interfaces. And that's an interesting one, optional. So it's a way of wrapping some value, some class. Let's say the name could be null, or it could be some value. So here I'm wrapping a non-null name, my first name. So I've got an optional string. There are some methods like or else. So you want to retrieve what's inside the optional, inside that kind of container object. So either you're going to get Guillaume in this case if the name is not empty, if it's not null inside the optional, or else you get unknown. Okay, and if you want to retrieve the value inside the optional, you really have to either use something like or else. There's also or throw, so to throw some exception, etc. Or you have to be explicit and use if is present or if present. I think it is present, not if present. I think I made an error there. I need to double check the API that I don't know by heart yet. So if the name is present, then I'm going to say system out println, and I need to unwrap the name by calling get, or here I'm printing unknown. So I could have used a ternary operation, etc. But bear with me for a little moment before I show you how I can do that with Groovy. So here we're wrapping that name. You're really forced to handle the case where it's null. The nice thing with optional is that you're not getting a null pointer exception, because if you really want to manipulate what's inside the optional, you have to do it explicitly. So it's a nice way usually of avoiding NPEs. But what could it be looking like if it were in Groovy? And before showing you that, I'd like to mention a few things. Did you know that in Groovy you can customize the truth? It's really powerful when you think about it. You just have to implement your own AskBoolean method. So that's a convention. Another interesting thing is the law of Groovy truth. It's everything that's null, empty, zero-sized, equal to zero, etc. All those things are false. And if you have your own AskBoolean implementation, if AskBoolean returns false, well, it's false, obviously. And otherwise, it's true. And another thing which is interesting in Groovy is the Elvis operator, right? The Elvis operator, because if you lean your head forward on the underside, you're going to see the banana hair. In Groovy, we could make use, so it's not implemented, but it's something we could be doing. We could use the Elvis operator. So instead of doing maybe, name, or else unknown, we could use the Elvis operator there, right? Here, with Groovy truth, there's a problem with my animation. With Groovy truth, instead of having to say maybe name is present or if present, you could just coerce that with the Groovy truth rules, so that if there's a value present in the optional, then it's true, otherwise it's false. And here at the end, instead of when you want to, let's say, to call a method on what's inside the optional, you have to either go that way using if else, or do a .get call. But we could also use this safe navigation operator to say, okay, if there's something in the optional, you can call toUpperCase on it. And otherwise, this is really just returning null, basically. So that's the kind of enhancements we could be wrapping and adding on top of optional in Groovy. So currently, this is not implemented, but there was a couple of months ago or something like that. There were some very interesting discussions on the Groovy mailing list about that, and don't hesitate to join that discussion if you have some ideas of things you would like to see around optional. Okay, so this is not yet implemented. It's something we could be supporting. So Nashorn. So do you know why it's called Nashorn, or why I have a rhino there on the picture? No? So so two reasons. One, why there's a rhino, it's because the original implementation of JavaScript in JDK, I think that was since JDK 6 when it was added, because it was using the Rhino project. And Nashorn means rhino, basically, in German. So that's why there's this nice little rhino. So you have a JavaScript implementation, and in Java 8, it's been totally rewritten, and inside the project called Nashorn. So I think it must be pronounced Nashorn, and not Nashorn. Initially, I was saying Nashorn, but it's called Nashorn. And if you use the JAVAX script API, you can instantiate a script engine manager and get the script engine for the Nashorn JavaScript engine. And then within the Groovy programming language, you can evaluate JavaScript. So as you can see, you've got some sane JavaScript logic. So if you add an object and an empty list, an empty array, the result is 0 in JavaScript. So JavaScript is even saner than Groovy. So, and it's by the way, it's an example taken from the WAT presentation, W-A-T, not W-H-A-T. And if you just Google for WAT, W-A-T, it's an awesome presentation on some weird cases about languages like Ruby, JavaScript, etc. And it's really awesome to watch, very, very, very funny. So I encourage you to have a look at that. And something entirely different, so you can use Nashorn from Groovy if you wish, because it's a bundle in the JDK. I'd like to mention GrooScript, which is a transpiler which translates Groovy code into JavaScript. So nowadays, all languages have to somehow translate into JavaScript. That's I mean, you're not hip if you're not translated to JavaScript. And in the GrooScript project, you will be able to find Gradle plugins, Grails plugins, and some interesting examples with Ratpack, with Node.js. So you can write a Node.js application in Groovy, basically, and have that translated into JavaScript. And there's a pretty nice example I'm going to show you. And what's nice is that with Groovy to JavaScript, you can really have a full Groovy application. So it's turtles all the way down, full Groovy, back to front and front to back. And I'm going to show you a small example. Who knows who's the painter of those famous paintings? Pollock, yeah. So that's Jackson Pollock. And there's a nice, so let me, I forgot to open that in my browser, so I think I'm going to find it there, up. I think it's listed in the demos. So unless the Apple can, damn. No, the demo is pretty cool, and I don't think I have it open anymore. Too bad. So it's a demo that was actually, to be fair, it's a demo that was created by the Clojure guys who also have a Clojure 2 JavaScript compiler. And the guy who created GrooveScript, I told him, hey, did you see that demo? It's pretty cool. And a couple of days later, he created a demo. So it's based on Canvas and so on to do just like Jackson Pollock would do, throwing paint on top of a Canva. And it's pretty nice. So if you go to groovescript.org, in the list of news, you'll find a link to the Pollock demo, which is pretty neat. So I invite you to have a look at. Oh, yeah, that's too bad that I cannot show you that. And I would have liked also to show you the code, because at the bottom, if you don't notice, I just want you to tell you that at the bottom of that demo, there's a link to the two classes. And also what I wanted to mention is that you can also do a bit like in GWT, where you can inject native JavaScript. So there's a notation to say, OK, this part is native JavaScript, so you can have inside some kind of special comments. You can have native JavaScript inside your Groovy code, so that you inject the pure JavaScript stuff directly in the output, etc. But well, too bad for my demo. Never mind. JavaFX. So it's not really new anymore, but there's always new developments. Don't remember when it was first announced, but I remember very well in 2008. Really? Oh, that old, 6 years already. And I remember that in their FAQ, they were saying, hey, why didn't we use Groovy for that? So there was an explicit plug to the fact that they could have used Groovy to use for their builders and so on. But well, and so JavaFX is more or less progressively trying to get rid of Swing somehow. And I'd like to mention the GroovyFX project, which I think I don't have the equivalent Java implementation of that. But there's a very nice builder for creating a stage, a scene, defining how the components are nested within each other, etc. And this one is doing some charting in the article from which I copied that example. There's a bar chart and a pie chart, and taking those data as data for the graphs. So it's pretty nice to see that Groovy can enhance something like the JavaFX. So thanks to Groovy builders and the Groovy closures. And then beyond Java, there are several interesting use cases for Groovy. So you can use Groovy for building full-blown applications if you use Grails, Ratpack, etc. You can use Groovy also for scripting, for testing. And here I'm mentioning one quick example, which is with scripting. And another very interesting use case for Groovy is when you integrate Groovy in a Java application for defining business rules using Groovy DSLs, Groovy domain-specific languages. And Groovy's got really great mechanisms for integrating Groovy code inside Java applications to have the code being pretty secured, to make it as short as possible by adding default imports, or there are really plenty of options to provide a really great integration story when you integrate Groovy, let's say business rules, in your Java API. And by the way, the buff is that's tonight, or is it tomorrow night? Yeah, that's tonight. The beginning of the buff tonight, the Groovy Grails buff, will be done by Scott Hickey, who's been working for Mutual of Omaha. And that's kind of our historical big use case for Groovy back in 2004 and 5, when there were the first big name company that was using Groovy for defining business rules in their application. And it's going to be very interesting to chat with Scott and see why they chose Groovy, what they did, and how it worked. And you've got 8 years of feedback, basically, or actually even more, how it worked, etc. So if you join the buff, that'll be very interesting testimonial. So one of those use cases is scripting. So when we started working on the new Groovy documentation, there were certain pages in the old Groovy wiki that were pretty good already, or pretty recent, and we wanted to reuse that content so that we could put that in the new format. And the thing is that the wiki was backed by Confluence. And so you could have access to the wiki notation potentially, or the rendered results, which is HTML, obviously. But the thing is that our new documentation is in ASCII Doctor. So we wanted to be able to reuse the content from the wiki and have an ASCII Doctor format so that we can integrate that in our process. So Cedric created a little script to do that. So if I zoom a little bit, so it's really just a Groovy script that you're going to launch on the command line, and you have the @grab annotation, which downloads dependencies. So you don't have to create a full-blown project with a build with having to deal with the dependencies. You just say, okay, I need this dependency in my script, so I just grab it. What I'm showing you there, I'm using the HTML cleaner library. Then I can use things like the nice each file recurse method before the new stream way of iterating over a directory. We already had what we needed to recurse over a directory of files. What else? So this is where we clean the HTML, some more cleanup. What's interesting also is the last call there, where where we have the, where is it, here? Yeah, actually we see it there, the execute call. There's a new method, well, not new, but a method added to a Java long string by Groovy to execute that string as a command. So we are using the command line tool called pandoc, which transforms between different text formats like HTML into ASCII Doctor. So that was a way to get a quick access to our content from the old wiki and to be able to reuse that in our documentation effort. Another big use case is coming up with Groovy 2.4. That's for Android. You can write Android applications in Groovy. So on the last day, on Thursday, Cedric will be talking about that. And there are a couple of great blog posts here about how you can get started. And the big news during the keynote yesterday was the fact that the New York Times decided to use Groovy for its new Android application. And one of the things they mentioned in the article was how you can make the code nicer. For instance, here, since on Android you don't have Java 8, you don't have Lambda, so you can have streamlined code for doing like launching async functions. So you would have had to use an anonymous inner class. And in Groovy, basically you use a closure and do async.start and my closure, and we coerce that into the right functional interface or Guava class or whatever it was. So it allows them to have, the Java 8 feeling of lambdas, but with a Groovy syntax now today, without waiting for Google to do something about this Java story on Android. So goodbye anonymous inner classes. And other aspects they were interested in, so the fact that you can write more concise and more readable code, also the fact that the code can be as type safe and as fast as needed, because they didn't really notice any performance degradation or anything by the fact of using Groovy over Java. So you'll have to read the article to get all the details, but that's the summary. The GreatConf conference agenda application in the Play Store was actually built with Groovy, and the code is available on GitHub. And all the details Thursday with Cedric. And beyond that, well, there's a big ecosystem around Groovy. Grails, obviously, one of the key ones. This is pretty much the example that Graham showed during the keynote. So here with just 2, 4, 6 lines of code, you've got a full RESTful application, data-driven, using the H2 memory in-memory database. So one class, one command with the Grails command line or the Spring Boot CLI command lines. And with Grails 3, you'll be able to have a full-blown REST application with just a few lines of code. That's quite powerful, in my opinion. And another one, there are some talks, I think there's at least one by Dan Woods and another one by Larry Otari around Ratpack, Grails, etc. So Ratpack, that's a new lightweight, not light web, that's a new concept that I coined, the light web Netty-based web application toolkit. That's lightweight. It's supposed to be lightweight. So the lightweight Netty-based web app toolkit, and it's yeah, pretty interesting application framework for reactive applications and so on. We have the Griffon Rich Desktop Application Framework based on the Grails structure and infrastructure. So here I've got a simplified, and I just I skip lots of details, but I took that from the Getting Started guide from the Griffon documentation. So you have the MVC approach. So this is a model for a console kind of application. You've got observable properties on your model. Then you've got a controller with its model. You can inject the evaluator, which is going to evaluate Groovy expressions using an evaluator class that I'm not showing. And then you can use, again, Groovy builders to define views. And there are different toolkits available for Swing, JavaFX, and other toolkits I don't really know about. Spock, pretty well known for unit testing and specification. Well, that makes for a very nice readable code, and I've always liked this wiki-like notation to define data-driven tests. If you want to do that with JUnit, it's always a pain in the neck to do that. So data-driven tests in Spock are really very readable. And another project, I don't think it's mentioned this year at Spring Launch GA. There was a talk last year, at least. It's certainly available online. So Jeb is for browser automation. So you can use that in combination with Spock, for instance, to do functional testing of your application. But the nice thing is those jQuery-like methods to get access to elements of a web page. Okay, you want to retrieve the content of the H1 tag. You want to fill in the form and click on the submit button, etc. Well, that's really nice. Well, Gradle, not much to say about it. That's the future of build automation. Maven, and all that stuff, that's the past. That's for dinosaurs. Who's not using Gradle? Get out! No, I didn't put my famous get out slide now. Jeepers for concurrency, parallelism, asynchronous stuff. And also that we had a Google Summer of Code student who worked this summer to make actors, data flow, etc. available through remoting. So you'll be able to use Jeepers in the next version with remoting. So you'll be able to have your, let's say, your actors or your actors on two different nodes and have them chat together. So it's not just single JVM anymore. And there are many different concepts, CSP, software transactional memory, etc. We've got plenty of great modules. I'll mention just a few ones for end scripting. For example, here I'm combining the markup builder to create an email, and I'm using the ONT builder and the ONT mail task to send emails, again with that builder syntax. So that's pretty neat and concise. The JSON builder for producing some JSON content. And it's going to generate that kind of JSON. And this one, when you parse JSON, it's super powerful when you think about it. On strings, so this is a string listing the list of commits. I can transform that into a java.net URL with the toURL method, which is a method added by the Groovy development kit. And then you've got this magic .text method on URLs, again added by the Groovy GDK. And it's actually doing a get HTTP request. You just say .text and you're going to retrieve the content of that URL. I think that's, I mean, in just a few characters, you're able to do an HTTP get. That's super powerful. And the second super powerful aspect is the power of the dynamicity of the language, because you don't have to create a full-blown object hierarchy representing what a commits array is, a commit object, an author object, etc. You don't have to do marshalling and marshalling to and out of an object graph. But because it's a dynamic language, with the Groovy runtime and the JSON API is able to figure out that, okay, so you want to retrieve the first commit object, which is return. You want to access the commit object inside. The author object inside that commit object, JavaScript object, the .name property of that author object very easily. And it's pretty much a bit like, XPath, but for object graph, XML graphs, JSON graphs, etc. So it's one of my favorite snippets of Groovy code in the sense that you show the power of Groovy, the power of being a dynamic language, and how it can also enrich existing classes like the JDK classes to add new methods like getText to do an HTTP get. And well, do that in Java. How many lines do you think it'll be? How many dependencies do you think you'll have to bring in to get that job done? Think about it for a second. That's tough. We've got the new template module I mentioned this morning, integrated in Spring 4.1 and Spring Boot approved. So yeah, you've got a model that you inject in the template above. You feed that model into the template, and then you can get this output. And this is, well, how you can wire that in, markup template engine, etc. No need to go into the details. So in summary, do we still need Groovy now that we have Java 8? No one saying no? Yeah! Good. So yes, that's the short answer. And the longer answer is yes, because what? Two things, in my opinion. You can benefit from Java 8 in Groovy. So Groovy always complements Java 8 and build upon Java 8. And there's a real synergy between the two. And as I say in that quote, if you will, the whole is greater than the sum of the parts. So Groovy alone or Java alone, no, if you use the two together, you've got a really powerful combo, a winning combo, and you get more than just out of one or the other alone. And this is great, being able to combine the two, but often Groovy tries to go a bit beyond. So when we coerce closures to functional interfaces, we go beyond because we also support abstract classes, or we always find ways to go slightly beyond what Java did to try to give a bit more power in the hands of the Groovy users. So that's really the two, let's say the two aspects, the synergy and trying to go beyond what Java offers. So as we, throughout our discussion related to the new syntax elements of Java 8, lambdas, repeating annotations, annotation on types, method references, default methods, static methods on interfaces. So we'll need to make a call on some for things like annotation on types or the default methods or static methods in interfaces. We know it's going to be yes. For lambdas, for method references, we're still. I mean, the question is still open. So we'll need to figure out what we end up deciding. And your feedback is important to us. So if you've got an opinion on what we should be supporting, how we should be supporting that, don't hesitate to email us, tweet, join the mailing list, etc. And there are further possible API enhancements, like how we could enhance the optional class, new methods that we could be adding around new I/O, around streams, around date and time, even do operator overloading around date and time for making arithmetics simpler. And just this morning, on Twitter, I tweeted a link to an article about Java 9 coming up with a currency API. And the first guy who answered me was saying, yeah, but it sucks because we still cannot use plus, minus on currencies. Yeah, I know you cannot do that in Java, but in Groovy you can, because you can do operator overloading thanks to the great power, the great power of Groovy. So I'm not really too concerned, and I'm happy that Java 9 will come someday with a new API for dealing with currencies. So that's nice, and we'll be able again to enrich it with things like proper operators for doing arithmetics. So your feedback is more than welcome, and your contributions as well, in whichever form, whether it's even just feedback, bug reports, documentation, ideas of how we could extend, improve, enhance, enrich, etc. So don't hesitate to come to us during the conference, after, any time. We're totally open about that. Speaking of Java 8 again, we have Venkat over there who's going to speak about Java 8, language capabilities. Another one, I think I've heard Peter in the back somewhere behind. Peter Ledbrook is going to speak about how to get groovy with Java 8. And I also took a bit of inspiration from this book, Java 8 in Action, published by Manning. And I think I retweeted the link, the tweet, sorry, from Manning, but I think it's the whole week for Spring 1 to GX. You can get 44% off the Java 8 Groovy Grail Spring books from Manning. So if you want to get a good deal, a good cut on the price, it's a good week. So thanks a lot for your attention, and I'm happy to take a few questions. We have 7 minutes. Yes, Venkat.
A couple of questions, actually.
No, just one.
Different versions of Java, so we can run it in Java 5, 6, 7, 8. But if I'm really running it against Java 8, is there a possibility that find all, collect, and methods like that would actually become lazy rather than being eager?
Yeah.
Inefficient evaluations?
So actually, making the Groovy methods like find all, collect, etc. lazy, just like they are with Java 8 streams, because of how they build a pipeline, and it's only sudden operations which actually make you go through the whole stream. So first of all, one point is in the latest versions of Groovy, we try to also add the same kind of methods on iterators, so that if you do a couple of find alls and collects, etc., since you are calling the iterator, you're really just doing one pass because it's jumping on the previous iterator, etc. So it's not perfect because it's not covering all the methods, and sometimes some of the iterator-based methods return collections. So it's not fully lazy, but at least it's a step in that direction. And then, I mean, once Java 8 will be pretty common in the hands of developers. Perhaps we'll just use the stream APIs more and more rather than why duplicating, or perhaps at some point, let's say in Groovy 3, perhaps we'll say, okay, this is actually delegating to streams rather than as synonyms for the stream methods. So there are various steps in that direction, but it's not yet clear exactly what we'll be doing. But clearly, at least, we're thinking more and more about laziness rather than always creating intermediary collections. Yeah. So that was the first question, and you had the second point?
Thanks for answering that. And
You're
the
welcome.
question I had was, one of the benefits in Java is clearly transforming the closures into invoke dynamic calls.
Mm-hmm.
How is Groovy going to evolve to make full use of that capability?
Yeah. So in Java 8, lambdas are leveraging invoke dynamic as a backend. And the idea, so we have also an invoke dynamic backend for Groovy if you use the right jar, the one, and also the right flag to enable the usage of invoke dynamic. But in Groovy 3, I mean, the backend will be fully invoke dynamic based. And the thing which is still open is, so for instance, depending on whether we support both lambdas and closures, we could do something different, for instance, for lambdas and use the same mechanism and the what is it called, the factory stuff? Lambda factory? No, what is it called? The lambda factory from the plumbing inside the JDK and the JVM to build the lambdas, and we could reuse that either for our closures or for supporting lambdas. So again, it's still not quite decided what we'll be doing, but it's certainly coming. And anyway, in either case, it'll be fully based on invoke dynamic under the hood. Yeah. 3 minutes more for questions. No? Okay. Well, thanks a lot for your attention.